It's just there's a lot of processes, not particularly. First of all, we've always talked about inequalities before. This is not a new thing for us. What are inequalities? Well, just like they say, it's telling you things that are not equal. And we have a couple different inequality signs. You've got this, which is the greater than sign. You've got this, which is the less than sign. You've got the greater than or equal to sign. You've got the less than or equal to sign. And then we also will throw this one in here. You've got the not equal to sign. We also have the negatives of those, but I don't think they give them to you just yet, so I'm not going to give them to you just yet. Okay. And here's the deal. It's a simple little thing here. Let's say you are graphing these. The only way to show an answer to a problem like this, if x is greater than 6, okay, that means x can be anything bigger than 6. It could be 7, 8, 9, 10, 11, 12. Really, the only way to show this as an answer is to show it on a number line. Okay, where here you have a 6, you know, you have 7, 8, 9, 10, 5, 4, 3. That's the way we count, isn't it? 4, 5, 6, but okay. To show this as an answer, what you would do is, okay, first of all, x can't equal 6 because there's no equal sign there, but it starts right at 6. In other words, 6.1 would be an answer that would solve this, would be true, because 6.1 is bigger than that. So the way that you show that it starts at the number but doesn't include the number, it's an open circle. You put an open circle at 6, that means it starts at 6 but doesn't include 6, and then you draw an arrow in the direction that your answers are. And then you have to put an arrow at the end because it goes on forever that way. Any number that's to the right there is an answer to that. Okay? So note to self is that, okay, if it's not equal to, it's an open circle. Okay, and another helpful little hint that I found over the years is a good little check to make sure you did it right is this. You'll note that this greater than sign is the same as that arrow there. In the same way, if you have a problem that says y is less than 2, when you graph that out, here at 2, again, it's an open circle, and it goes in this direction because it's the numbers that are less than 2, and the less than sign is the same looking shape as the arrow there. Isn't that exciting? Now looking at a couple more, for example here, let's do an equal to sign. B is greater than or equal to -3. Now when you graph this, there's just a bare minimum that you have to do. The bare minimum is you need to draw the line. There needs to be this number there. Okay, you need to have a dot there, and in this case, because it's equal to, equal is closed, circle, you need to color this in, and it's any numbers that are greater than -3, so you have to go in this direction. And that would be the bare minimum on your paper if you were asked to do that I need to see. Some people don't put this number down there. Well, I can't really give you that right because I don't know where it starts. Some people don't draw the rest of the graph over here. I think that's just being lazy. Okay. What about this one? We have not talked about this one. What if it said x does not equal 1? How would you graph that? Ask yourself what x could equal. What could x be? Okay. Anything but 1. How do you graph that though, Steph?
You put arrows in both the sections of an open circle.
Exactly. You have your line, you have 1, you have an open circle at 1 because it can't equal 1, and then this thing actually goes in both directions because it can be anything except for 1. Easy enough. And then the only other thing we have to talk about is this. When you do inequalities, okay, I just keep right on rolling down here. When you do inequalities, you're not allowed to have this. Okay, the variable must be on the left side. Okay, this is no good. The variable must be on the left. Variable must be left. Now, when it's an equal sign, when you have x equals 8 and 8 equals x, that is okay. You can do that. You can flip-flop things like that and no big deal. Not so the case when you're talking about inequalities. Okay? When you flip-flop these, when I put the x over here and the 8 over there, what you must realize here, see the little alligator? He's eating the x because the x is bigger than. Well, the alligator is still going to eat the x when you flip-flop it the other way around. So if you flip-flop the two numbers, or the letter and the number, you must also flip-flop the sign. Okay? Because the little alligator, he likes to eat the x in both cases there or whatever. You know, he's always going to eat the big one. So when it's on the wrong side, you need to put it on the right side and then graph it from there. So 8, open circle, whoosh, shoot. And notice in this case, the arrow actually is opposite from the original problem, but back when you flip-flop there. Handy, exciting, refreshing. Questions? They do give you fractions. Will that cause you any trouble? That doesn't really matter. You know, if they give you something like this, f is less than 3/8, it doesn't really too much matter to me. Just you might want to put a 0 and a 1 there, and then just pick a spot for 3/8 to be. Stick a 3/8 right here, and put your circle there, and go this way. There's always extra credit for how nice the arrows are.
Yours?
Sure.
Yeah, these are those.
Did anybody take me up on it?
I do it. Yeah, Kylie used to make these 3D. Yeah.
Is that so?